Hello everybody, I'm Molly and I will be guiding you through today how to complete the jelly seaweed experiment. It's an amazing experiment to encourage young students to explain how seaweed fills rubbery and how chemical reactions can change physical properties. In this video, I'll be talking you through how to complete this experiment aimed at primary school children and younger. If you're looking to complete this activity with older students, head to our website and navigate to the Biopolymers that Prevent Cancer page. We also have a worksheet added to our webpage, which is more in the style of a recipe to help you through this. Just a little bit of background for the teachers before we begin. Inside many types of seaweed is a really long molecule called alginate. Alginate is a type of molecule called a polysaccharide, and it's similar to many things like starch, which is often found in potatoes and pasta. To make our jelly seaweed, we also use a solution of alginate. This is what we will need to begin this experiment. I would prepare these solutions in advance so that with the children you can add them directly. First, you're going to need some sodium alginate powder. This is available online as it's often used as a specialist food ingredient. Next, you're going to need some calcium lactate. This is also available to buy online. Then you're going to need some measuring jugs and a spoon for stirring. I'm going to use a beaker and a spatula. Then you're going to need some 3 ml plastic pipettes. They look a little bit like these, and they're also available online. Then you're going to need some white paper to put underneath the pots, and also some food colouring to be able to see what you're doing. I would recommend some paper towels for spilled solutions, and you will also need a set of scales. I would recommend preparing these solutions a few hours beforehand in order to allow them to dissolve. Okay, so we're going to measure out 1 gram of the sodium alginate powder. It doesn't have to be super precise, but as close as you can get it will be best. And then measure up to 100 ml of cold water. So once you've added your 1 gram of sodium alginate to your water, it may get a little bit clumpy if you live in a hard water area, which is sort of what it's done here. You can solve this problem by either gradually adding the powder to the water, or you can mix a little bit of sugar with the sodium alginate powder beforehand. It also helps if you warm the solution. So this time instead, I'm going to go and slowly add the sodium alginate to the water, and hopefully it should stop it from going clumpy. I'm going to add a little bit like this, give that a good stir. And as you can see, that has slightly helped. Add a little bit more. Okay, so I ended up leaving this on. In chemistry, they call this a hot plate at 50 degrees C. However, this would also work if you put it in like a large bowl surrounded by slightly warm on the side of boiling water, and that could work as a water bath, and it ends up being able to dissolve the bits easily. I also left it for about an hour and it seemed to dissolve in a lot easier, sort of like that. And so I think with a combination of that, works pretty nicely. Also, if you see inside of the solution itself, it has like a lot of like clumps of bubbles. The more you stir it, the more these like bubbly clumps come about. And so I think the easiest way of doing it is preparing it a couple of hours beforehand and then just leaving it to dissolve. I would also potentially try it a couple of days before completing the activity as well, in order to like really try and get this to dissolve in and see what works for your water hardness. So once it's all dissolved, it should have the consistency of runny honey, which I would say is pretty true of this. And so to be able to see it more clearly in the rest of the experiment, we're going to add a few splashes of food colouring. And I'm just adding the tiniest drop because you don't want it too saturated. Oops. Well, that is nice and red. Just like that. So now this is all ready for the demonstration activity experiment later with the children. So next, we are going to dissolve down the calcium lactate. And for that, we need to add 2 grams into another 100 milliliters of water. Mils. So I'm just measuring out 2 grams of the calcium lactate to add to 100 mils of water. So these scales take a while to balance because they're really super duper high resolution scales. The worst weighing scales you have at home probably won't have this resolution, but it will still work. Need 2 grams of this. That's 1. Okay, so now we're going to add this to our 100 milliliters of water and dissolve it down. Okay, so our calcium lactate is basically a very fancy salt. So like our table salt, but a little bit more complex. And so it should end up being a very similar consistency to if you just add table salt to water. Once again, might take a little bit of a while to dissolve, which is why we're doing it in advance. Now this is all prepared, you can complete the activity. I would recommend doing this in small groups, and the younger the children, the more helpers you will need per child. So this is just dissolved, it only needed a couple of minutes worth of stirring. This experiment works better if you can use a small clear container, so like a plastic cup or a small glass, something that they won't be able to smash, but something that they could easily see the solution inside. So I'm using this beaker because we are in a chemistry lab. So fill it about 2 to 3 centimeters deep with solution. I'm going to go a little bit more so you can see it, and use about that much. And then what you do is you get your coloured alginate solution and one of the pipettes. And then what we're going to do is we're just going to suck up some of this. And then we are going to drop this into the solution. Like that. And as you can see, it's forming these little bubbles. This is because the chemical reaction where the alginate is binding to the calcium is happening on the outside of the bubbles, forming like a film. Isn't that super cool? And then if you pop it in like this and do that, you can make a worm. You can make a worm. If you do this, you can make a worm. So that's super cool and super fun. And they can go back into the alginate solution and just pick some more of that up. And then continue dropping and playing around with it, doing a big long thing. If you touch the calcium solution with the pipette, it's fine. Just get another one, or pipette all of this that has gone hard into a disposable container. So because this is all food grade and food safe, it's completely fine for the children to touch this. So like, for example, I can pop my hands in it, have a feel around with them. The longer that you leave these balls, the harder they get, because the further the chemical reaction goes in. And if I take you around to the sink, you can even pour some of this out and you're left with the balls. Which you can have a play with. So these are the worms that I very quickly pipetted. And then these are another one. And then these are the balls that I made by dropping them in. They look a little bit like fish eggs, which is kind of fun. So yeah, so This is very good, just to let children have fun with playing with different solutions and seeing how if you mix two things together, they can form different properties. A little bit more background for teachers. When you add the alginate to the lactate takes up calcium ions from the solution. The alginate has a negative charge and the calcium has a positive charge, so they bind together very strongly. The calciums tie together the long spaghetti-like alginate to make a dense net. This is what makes the skin around the droplets and the worms. Thank you so much for listening. I hope this has been helpful and I hope you enjoy completing this activity.